In this video, we'll be dividing complex numbers. Recall that I is equal to the square root of -1. That is, I is a radical. Therefore, when dividing by a complex number, you need to rationalize the denominator. So when we're dividing by a monomial complex number, you want to multiply the numerator and the denominator by I. We're going to replace any I squareds with -1, simplify, combine like terms. Let's start by dividing 6 by I. We want to eliminate this I in the denominator, so we multiply the numerator and the denominator by I. Multiplying straight across, we get 6I in the numerator and I squared in the denominator. You want to replace any I squareds with -1. So this becomes 6I divided by -1, and 6I divided by -1 leaves us with -6I. Next, let's divide 3 minus 2I by 6I. The only thing we're concerned with getting rid of in the denominator is the I. So we're going to ignore the 6 and again just multiply the numerator and the denominator by I. We have two terms in our numerator, so we're going to have to distribute that I. This will give us 3I minus 2I squared, and in the denominator, 6I squared. We want to replace any I squareds with -1. 3I minus 2 times -1 over 6 times -1. Let's do our multiplication. 3I plus 2 over -6. I want to rewrite this in the form a plus bi. So let's put the real part first in the numerator and the imaginary part second. We end up with a final answer of 2 plus 3i over -6. Now, there may be some circumstances where we truly want to be in the form a plus bi and not have that in the numerator divided by some number. In those cases, you would just break it up into two separate fractions and then simplify each fraction. So this would give us -1/3 plus minus 1/2 I, and that would be our true complex form. You'll just have to make a decision depending on the context of the problem you're working on. Now let's look at dividing by a binomial complex number. This is just like rationalizing radicals when you have a binomial in the denominator. We're going to multiply the numerator and the denominator by the conjugate of the denominator. Recall that the conjugate is the exact same thing, but the middle sign is changed. We'll multiply, replace any I squareds with -1, simplify, and combine like terms. So let's divide 1 minus 2I by 2 plus I. Since we have a binomial complex number in the denominator, we're going to multiply the numerator and the denominator by the conjugate 2 minus I. Put all my parentheses around to help me with my multiplication. And we'll distribute in the numerator. 1 times 2, 1 times -I, -2I times 2, -4I, and -2I times a -1. That's going to be plus 2I squared. Remember that there's a shortcut when multiplying conjugates. The middle terms always fall out, so all we need to do are multiply the first two terms together and the last two terms together. 2 times 2 gives us 4. Positive I times negative I gives us negative I squared. We want to combine any like terms and replace any I squareds with negative 1. I notice in the numerator I have like terms here, and there's two different spots that I have I squareds that I'm going to replace with negative 1. So that'll be 2 minus 5i. We have 2 times negative 1 here in the numerator, so that'll be a minus 2. And in the denominator, we'll replace that I squared with negative 1 as well. So that becomes 4 minus a negative 1, which we know is really 4 plus 1. Like terms in the numerator to combine again. 2 minus 2, well, those are just going to fall out, and we're left with just negative 5i in the numerator. And in the denominator, we get 5. We want to look to see if we can simplify the fraction overall. Since we have just one term in the numerator and the denominator, we can cancel out these 5s, and we're left with a final answer of negative I. Next, let's divide the square root of negative 8 by the square root of 6 minus the square root of negative 2. This time, we have negatives underneath of our radical. Right away, we want to take the i's out of those radicals. This becomes I times the square root of 8 over the square root of 6 minus I square root of 2. I would not simplify the square root of 8 here because it's likely that we're going to have to simplify after we do our multiplication. So let's just wait to simplify and only do it once. Our denominator is a binomial, so we're multiplying the numerator and the denominator by the conjugate of the denominator, square root of 6 plus I square root of 2. We'll add our parentheses to help us with our multiplication. Distributing our numerator, I square root of 8 times square root of 6. That'll be I square root of 48. I square root of 8 times I square root of 2. It's going to be I squared square root of 16. In the denominator, we're multiplying conjugates, so we can take the shortcut and just multiply the first two and the last two together. Square root of 6 times square root of 6 gives us square root of 36. Negative I square root of 2 times positive I square root of 2 gives us negative I squared square root of 4. We want to simplify all of our radicals and replace any I squareds with negative 1. First thing we need to do is simplify the square root of 48. I'll do that over on the side. We're looking for the largest perfect square that's a factor of 48. That's going to be 16. Goes in 3 times, so this simplifies down to 4 square root of 3. So we have 4i square root of 3. Next, we have plus I squared times the square root of 16. The I squared we're going to replace with negative 1, and the square root of 16 is a perfect. It's 4. In the denominator, square root of 36, again, is a perfect. That's 6. I squared we'll replace with negative 1, and the square root of 4 is just 2. We get 4i square root of 3, and then in the numerator we have plus negative 1 times 4, well that'll be minus 4. And in the denominator, 6 minus negative 1 times 2, that'll be 6 plus 2. So this is 4i square root of 3 minus 4 over 8. We want to write this in complex form. So I'm going to rewrite the real part first and the imaginary part second. Negative 4 plus 4i square root of 3 over 8. But here we do have a common factor in the numerator and the denominator. So let's break this up into two separate fractions and simplify. Negative 4 over 8 plus 4i square root of 3 over 8. And we can simplify numbers that are both outside of the radical. Negative 4 over 8 simplifies to negative 1/2. And then I can simplify these as well. Plus I square root of 3 over 2. Our final answer is negative 1/2 plus I square root of 3 over 2.